Hello all, welcome to this video on understanding NumPy arrays. In this session, we will explore the fundamentals of NumPy arrays, a powerful tool in Python for handling large datasets efficiently. Designed specifically for CBSE Class 12 students, primarily for those taking information practices, this video will break down complex topics like array operations, reshaping, slicing, splitting, etc., into easy to understand steps. By the end of this session, you will not only understand the basics but also gain hands on experience with practical examples and exercises. Let us dive in and unlock the potential of NumPy arrays. We are going to cover these main topics. We'll start with a quick introduction of what arrays are, how they are different than the list that you have seen as a built-in data structure in Python. And then we'll talk about NumPy arrays. We will quickly introduce how you can create NumPy arrays in several ways. And then we'll see how you can access a specific elements using indexing or set of elements using slicing on range of indices in a given array. Then we look at variety of arithmetic operations like addition, subtraction, multiplication, division, element wise. Then we'll actually look at even matrix operation and several more. Concatenation of arrays. Many a time you have to actually you can reshape your arrays in a different combination of rows and columns. We'll take a specific example and see how that can be done. And then we'll take a couple of things where we'll talk about how you can split the arrays and some statistical operations as well as your ability to save and load NumPy arrays into files. If you look for a formal definition, an array is a data type that is used to store multiple values using a single variable name. It contains ordered collection of elements where each element is of the same type and can be referenced by its position. If you look at some of the key characteristics, each element is going to be of the same type. Entire array is stored continuously in memory, and that helps you access individual elements faster. And you can access any element just by using its position, which is where exactly from beginning it is. NumPy, which stands for numerical Python, it is a library for numerical computing. If you look at Python list compared to that, NumPy is much faster. It also has support for multi-dimensional arrays. In our discussion, we'll be talking about single dimension and the two-dimensional arrays, but a NumPy can suppose arrays in nth dimension, that is 3D, 4D, and all of that. And it is having pre-built functions for complex mathematical operations. So once you have your data in NumPy format, you can do several of those operations depending on your use case efficiently. Before we move ahead, since we have just done a formal introduction of arrays, and you have already seen what list is in your earlier classes. You might be tested as well in your exam. So even from that perspective, you can actually pay attention. What is the difference? How they are different from each other? So homogeneity. If you look at Python, Python can have data of mixed types. So it can contain list of integer, it can contain list of floats, string, combination of all of that. While NumPy array will have all its element of same type. As far as our ability to access it with speed, Python lists are way too slow, while NumPy arrays are much, much faster. For many of the operations around list, we have to do manual looping. You have to write a for loop or while loop around the list, while NumPy arrays support element-wise operations by default. Multi-dimensional, list no, and Python array yes. Basically, at least what you should keep in mind is list allows arbitrary type of data elements in the same variable. That helps you uh, if you don't have any control on your data types, or your data type are such that they're going to be of mixed type. List could help you a lot, but since it is not having data elements of a standard kind, if you want to access 20th element, since every element, if it was defined of a given type, it would have some fixed size. Since that is not the case, the only way of accessing list is going from left to right or every time looping. That's why it is very, very slow. Um, NumPy, on the other hand, it actually only allows homogeneous element. All the elements could be of, will be of same type of whatever type it is. And so it knows in advance, right, that if it has to access nth element, how it can. Because that will be at certain offset from beginning. Another advantage with the NumPy arrays, they are stored in contiguous memory block. So that also helps you access and do a lot of those operations, as well as if to bring it in memory if it is so big that you don't disk and some of those things. Now let's get started with some of the array basics and what else than actually creating array. Before you get into that, since we just introduced NumPy, uh, if you want to use this, you have to actually import it. For any distribution of Python, NumPy will be available by default. So you have to just only thing that you have to do is import NumPy. What we have written here is, if you see our screen and my mouse cursor, import NumPy as NP. So from here onwards, we can access our NumPy functionalities through NP. If you want to create one-dimensional array, then you can simply call np.array and give a list-like element. So if you see here 1, 2, 3, 5 is list-like element, right? And you can simply call np.array on that. If you print it, you get the element, right? As you have just covered it, NumPy supports multi-dimensional arrays, fast and memory efficient, and it is having built-in functions for operations. Now, you don't need to actually only call np array on list. There are several other ways. Many a time your use case might require that all your arrays are either zeros or one. So np.zeros, that you have to, I think, commit to your memory. Many a time that's the disadvantage of working with library. But np.zeros, and then you can give the size of the array element. If you see the definition of zero, right, then you can get it. Again, np.array, as you saw, you can actually provide a specific element, and np.zeros, np.ones. The one that you see on the ones, what we have done is we have created a 2D array of it. So we are actually asking it to create 2 into 5 array, and of data type integer. So first one is row, second one is column. We have print actually zeros, if you have print ones and print vowels on the right hand side, so you can have some idea how it looks like. Now, on top of zeros, ones, and specifying list values, there is another very useful, and you are tested in your exam on this construct, that is called A range. You can also call it A range because exactly if you look at your your range introduction in your other Python chapters, it is just you can call it array of range, right? Or remember it as an array. So what happens in case of range? If you call it range with some number, by default it will give you data from 0 till that number minus 1, right? And exactly arrange helps you create your arrays by having a start, a stop, and a step size, right? So by default, if you give 6, then you'll be having element 0, 1, 2, 3, 4, 5. If you want to create, say, 24 item starting minus 2, if you want to create items between minus 2 and 24 at a step size of 4, do remember the last indexes is actually exclusive. So it will be having from minus 2 to 2 to 6 to 10, 14, 18, and then 22. So that's how we can actually use custom range around range. Okay, so we have looked at several ways: np.arrays, then provide a list, then np.zeros, np.ones. By default you need it that way. And you can also use arrange, and you can actually use custom range with that. Uh, so we are creating some array here: array 1, array 2, and array 3, because we have used it in next slide. So you can just actually have a look at these arrays. Array 1 is just simply 10, 20, 30. Array 2, you have actually given integer 5, a float minus 7.4, and string a, and then a float 7.2. What is happening here is, if you print this array and look at the d type, it is showing it as U32. U32 means Unicode 32. Why? Because you had actually a mixed kind of array, and where the highest storage requirement for an string, so it all these data elements get explicitly converted as a string. So now all the elements are of type string, right? Then finally we are having our uh, three-dimensional array 3, where we have given two-dimensional, where we are giving 2.43, 4.917, and 0 and minus 1. So you can see actually 3 rows, 2 column, array 3, right? um, so what we are going to do now is, we have talked about array creation, right, through NP arrays or arrange or many others. And then we have created couple of single and two-dimensional arrays, and we look at the attributes of so the arrays that you are creating in the NumPy, they are also called ND arrays, right? And ND arrays are having set of attributes. One of that is n dimension, that is number of dimension, or what we call is axis. So internally NumPy considers uh, multiple access, it calls it accesses, and zeroth one is always your row wise, while column is one, so two-dimensional one. You can again define it for three-dimensional, where access could be 0, 1, and 2, and then you can get the idea of dimension. But the idea here is, if you don't use anything, by default your access is 0, which is row wise, and if you specify access as 1, this will be column wise. You have to keep in mind, because many a time you get uh, a bit ambiguity around these things. So n dimension. For example, if you look at array 1, we know it is one dimensional. Array 3 is two dimensional, and that's why you are correctly getting those output. Shape is how many rows and columns. So A is actually kind of having three uh, uh, So basically, anyway, column is just one, so it is just saying 3 comma. Array 3 is 3 rows and 2 columns, right? So 3 by 2. Size here is actually, just like your length of a list, right? So size of this is number of elements that are in there. Array 1 dot size or array 3 dot size, you can see there are 3 or 6 elements. And then D type is the data type. So array 1, it will be int 32, array 3, it will be float, and what will be array 2? U32. And then item size. So difference between size and item size is, it actually takes about size in bytes of each element in the array, right? So int is 4 byte, float is 8 byte, and you could have printed and seen string as well. Yeah, so just think around it. When you need to create arrays with zeros or ones, right? Uh, Typically, right? I mean, there are some common scenarios uh, when you want your arrays to be initialized. Initializing with zero, initializing with one in a very simple way could be when you have when you want to create an identity multiplier, right? A zero could be identity for a reason, and there are several scenarios where you need zeros and and ones arrays. Okay, now look at, we'll actually, what we'll do is we'll look at indexing. And indexing is just about accessing the elements in your arrays by position. And for one-dimensional arrays, our indexing starts from 0. So, if you are having a 5 element, we'll have an example. And the first one will be 0, second will be 1, third will be 2, fourth will be 3, and fifth will be 4, right? And for a two-dimensional one, to access, we need a row index, and also we need a column index. So row by column. Let us take an example. So we have taken this example from your textbook, where we are actually talking about 4 students, and their marks in 3 subjects: math, English, and science. So how we can create it? np dot array, and then we have given row wise data: 78, 67, 56. That is one row. 76, 75, 47. Okay, there is some typo. You can actually consider it, whatever, it doesn't matter. 67, 59, 72, and 47, 60, 54. So there are actually some little typos, but that's okay. So what we have done out here is, hold on, we are specifying our element row wise. Yeah, so 78, 67, and then there are some differences. That's okay. Now if you want to access, right, Prasad's, in example we are writing, if you want actually English, then what English will be? Your name is 0, math is 1, English is 2, and where Prasad is 4. So you have to give 3, 2, and for math 3, 1. Then another thing is, if you want to access out of bound indices, then you get index error. So for example, that your marks here is up to 3 only. So if you want to access fourth column 0, 4, you'll get an index out of bound error. Now, if let us look at our vowel example again, A, E, I, O, U, right? So if you want to access third element, right, vowels 2, what is that? I. Now, if you want to slice it, you can take a range, say from 1 to 4. What it will be? E, I, O, U, or E, I, O. So always keep in mind, the start is included and is excluded. So vowels 1 to 4, what will happen? 1 will be there, 2 will be there, 3 will be there, which will be E, I, O, and 4 will be excluded. So that's about indexing in one-dimensional array, where you have to just specify either a single element, or you have to specify a range. We are actually looking at some example again. Now in two-dimensional, again, what you have to give is which row and which column, as well as which all row and which all column. So it's nothing, but if you see comma separated row column, increase. So in a 2 dimension, if you want and a specific element, you can just access by say 3 2 or 2 4. But if you want to have, say for example, in this case, we want uh, in our 3D RAM 3 by 2 elements that we have, right? So we want second and third rows 1 2 and we want column 0 and 1, right? So we have actually given column star 2 and rows from 1 to n, so that will be 1 and 2. Operations, we have just declared two array and two element wise addition, it was simply called plus. Element wise multiplication you can use into. You have to always keep in mind, and then in a similar way you have subtraction, division. Always keep in mind that these element wise operation will be applicable only when the array shape is same. If array shape is not same, then for the array with higher shape, you have to pad that. Lower shape, you have to pad that to match the higher shape. Matrix multiplication, again, matrix multiplication you can do either by calling the np dot dot as you see here, or you can simply call array1 at the rate of array2, right? So rather than using a star symbol, you can use at the rate symbol. Reshaping. So reshaping is actually once you have created array, and sometimes say for example we have created once, right, which was from whatever, right? Now if you want it's anyway, so if you actually take one row of 10 elements, you can get it this way. We have actually say array 1 and array 2, right? But you can actually also specify say 2 by 5, so it means 2 rows of 5 elements each. We'll see some more example around reshape, don't worry. Concatenation, you simply call np.concatenate, and what it will do, it will concatenate them by default on row wise. So 1 2 3 1 2 3, and here we are getting by default on row wise, so that will be 4 5 6. If you wanted it column wise, then you could have given np.concatenate array1 array2, and then you should have fixed that your axis that you want is 1 rather than 0. Transpose is another one where if you transpose, it actually gets rotated. You have to simply call transpose, and rows becomes column, column becomes rows. For example, this element, right, 0 1 2 3 4 5 6 7. So 0 1 2 is one row. It will become column, one column. So 0 1 2 3 4 5 second column, 5 5. As you can see in the diagram here, right? So transpose. We have looked at what? Arithmetic operation, concatenation, then transpose to convert row into column and vice versa. Flatten, where actually any kind of n-dimensional array, you just convert into one dimension, as you might see on the screen. And reshaping again, for example, this one, right, where we had 9 element. If you want to reshape in 3 by 3, you can simply call dot reshape and specify the coordinates. Now let's look at another important operation, that is sorting. By default, NumPy does sorting on ascending order, which means that if you want on descending order, you have to use another operation on top of that. We'll see some example for sorting in descending order as well. Another thing is, if you're looking at 2-dimensional array, then by default sorting is done row wise, means every row will be sorted, right? But by default sorting is done row wise. When you provide axis as 0, then sorting is done column wise, which means that each column is sorted in ascending order. So you can see this example, right? Array 4 at 10 minus 7 0 20 minus 5 1 200 40 31 minus 1 4. If you sort it, right, by default, which will be on axis 1, then you are going to get all the rows sorted. So minus 7 0 10 20 minus 5 1 40 200 minus 1 1 420. But if you want to sort it row column wise, you have to give axis is equal to 0, and then what will happen? You'll get minus 5 10 30, right, minus 7 1 1 minus 1 0 200 420 40. Do keep in mind, sorting in a 2-dimensional array, you have to use axis is equal to 0 for column wise sorting, axis is equal to 1 by default is for row wise sorting. Arithmetic operation, we saw some of that into and this. In a similar way, you have plus, right? You can call any of that, and as you saw for matrix, you either can call np dot dot, or you can simply call at the rate of. Splitting arrays. So now splitting array is a way of dividing the array in equal part. For a simple one-dimensional array, what you do, you call np dot split, and then provide actually how many groups you want for one-dimensional ones. We are saying 3, then if there are 6 elements, it will be 2 elements. So 10, 20, 30, 40, 50, 60. In case, say for example, there were 7 elements, you wanted 3, right, split, it will result into error. Okay. Now in two-dimensional it becomes very, very interesting. So here, rather than providing only number of chunks like you did array 3 with one-dimensional, in two-dimensional you have to specify that which all by a second element, and then you have access to determine whether by row or by column. So on a given row or on a given column, you can specify. For example, if you look at first, second, third row, this is split happening on array 4 for across 1 and 3, while your axis is 1. So axis is 1, we are actually going to do column wise, and 1 and 3 means your 0th element is going to be 1, and then 1 and 2 is going to be the second, and the third one is the fourth is going to be the last one. Had it been axis equal to 0, what would have happened? Axis 1, again row 1 would have gone up, and then 2, 3 for second, and third would have been the fourth one. Matrix multiplication, just you can call the dot operator, right? Yeah, we saw it. A statistical operation, so np dot mean, np dot standard, np dot mode, np dot median, all of these standard operations are available that you can actually call and see for as per your use case. Now once you are done with, many a time NumPy arrays could be huge given your data sources, and sometimes you want to save them so that you don't have to recompute them again. So command for that is save text, right? So here you have to provide file path, that is array text dot data or text in this case, and then which NumPy data point you want to write, right? So np dot save text, file name, and your variable, right? More importantly, load text helps you load actually data from disk, and so you call np dot load text, right? Again, in this case you have to only specify the file name. There are a couple of things, right? So first one is this file, then the optional one is skip rows. So if you are having header information, then you can have is skip rows equal to 1, for example, right? So it will actually skip the first row. Then delimiter, what is a delimiter? Comma, space, whatever, and then data type, which data type it is. From here on, you will see that in many a time when we are loading data, right, your data is missing, and in that case, gen from text rather than load, could be useful. So if you do gen from text, right, you can provide the file path, skip header, delimiter, and then you can also provide filling values, which value you want, and the data type. So in this case, wherever your data is missing, say for example in this particular case 276, the third data was missing, that got assigned minus 999, and then again 4, last row, fourth, after that the second row was missing, so 4 minus 999. So in one go you can specify with which value to fix, replace if it is actually NA. Sure. So with this we have come to the end of NP NumPy array. What we have done is we introduced NumPy, where we saw what is the difference compared with list. Look at the homogeneous nature, and then how faster computation and access is possible. Then we looked at command to create it. We looked at various commands for creating zeros or ones, and then we actually look at two-dimensional arrays, how that can be done, what are the attributes around n dimension, around shape, size, item size, and several others. Then we changed gear. We talked about reshaping in a given shape. Then we talked about splitting. Then we talked about arithmetic operation. Then we talked about uh, splitting, splitting on a particular row column combination and how it is different on 2 dimension versus 1 dimension. We looked at sorting, and also that how it is different in row wise sorting versus column wise sorting for 2 day, where we specify the access out there. So with that, I think we have done good coverage. This was verbal. Don't worry. What we are going to do is we'll actually look at your end of the book questions, and we are going to do a live coding session. So stay tuned. All of these will actually have an hands-on. Thanks, guys. Do like and subscribe my channel, and see you in our next video. Thank you.